Hey everybody, welcome back to Young Engineers of Today. I hope you're ready to continue with, well, we're going to actually do some more over the wire today, which means I'm actually going to spend time reviewing what we went over on Monday. So we'll start at level 0 again and we'll move our way back up. So don't worry if Monday you felt like you were, being left in the dust or anything like that. I'll make sure that, you guys are able to get through everything and we can talk about why exactly we're doing what we're doing. So I'm going to go ahead and open up the War Games link again. I'll go ahead and throw that into the chat box again. There you go, just so you can look that over as well, because that's going to provide you with helpful information in order to get through each challenge. And we're going to start out with Bandit like we did last time. So let me go ahead and log back in to the Bandit server. Now remember, we start at level 0 because, of course, this is made by programmers. Everything in programming starts at 0. And plus, this is sort of like a test to make sure that you can actually connect to it. So just as a reminder, if you're running on a Linux or Macintosh computer, the command is going to be SSH and then a space and then bandit.labs.overthewire.org. And the reason why it is this command is SSH is the actual command that makes your computer connect to an external server through a terminal, so secure shell. And then you have to give it a destination. In this case, it's going to be the Bandit over the wire challenge, so bandit.labs.overthewire.org. And again, if you're on a Linux or a Mac computer, you can just go ahead and open up the terminal and type that command in order to get started. Those of you on Windows, you're going to have to use PuTTY. And again, under the host name, just go ahead and put bandit.labs.overthewire.org. And I'm actually going to go ahead and save this. I'm actually going to give it bandit over the wire. We'll make it all lowercase. And I'm going to go ahead and save this setting. So now I can connect to it whenever I want by double clicking on that session. I'm going to go ahead and click open. And here we go. We get our login and our password just like before. And remember, the username is bandit0 and the password is bandit0. So because this is level 0. Also, don't forget that it does not echo the password as you're typing it. It doesn't even give you asterisks. This is to ensure that nobody knows how long your password is. So we're going to go ahead and hit return and logged in. We get some instructions here, playing the game. The machine holds several war games. If you're playing some game, then usernames are some game 01s, or some game 0, some game 1, etc. Most levels are stored in /somegame, and passwords for each level are stored in /etc/somegame_pass. This is just general information. Don't really worry about memorizing a lot of the stuff. Like, it'll make more sense as you get more comfortable with it, but as it stands right now, this is more than enough. So we're on Bandit 0, and the challenge is to find the README file. If we go here, the challenge is to find the README file which contains the password for Bandit 1. So if you'll remember, one of the commands for listing all contents is just ls. I'll hit ls and enter, and look at that. There's a README file here. Does anybody remember the command in order to look at the contents of the README file? Exactly right, Jean-Marc. Yep, just cat and then the name of the file. In this case, README. And our terminal output is the one line that exists in the README file, which is our password. So I'm going to go ahead and copy that to my clipboard. Actually, let me go ahead and try this out. Okay. Yeah, in Putty, all you have to do is highlight. Whoops. Let me try that again. All you have to do is highlight a line in order to paste it to your in order to put it to your clipboard. So that's the nice thing about Putty. You just have to highlight something and it will be placed into your clipboard. So now let me go ahead and I believe, log out. Yep. Reconnect. And now I'm going to connect as Bandit1. It's going to ask for the password, which is what we got in the last level. So I'm going to right-click. Right-click is paste in Putty. Hit enter. And there you go. Now we're in level 1. And maybe I went through that a little bit fast, but I just typed logout, like so. And for me in Putty, that actually closes it entirely. So I have to reopen Putty and reopen my Bandit over the wire session. There are faster ways to do that, which we'll go over in a moment. But for now, that will do the trick. So let's see what we've got here. We've got a single file that has a dash as the name. Now, here's the thing. The dash, the hyphen, whatever you want to call it, is a reserved character in the bash, in the terminal. That's what this is also called, as the bash, or bash. Short for born again shell. But anyway, it's a reserved character for things like options. Like for instance, if I wanted to list, see when I do ls for list, I only get some of the files. I don't get all of the files. I don't get, hidden files. I don't get the relative, information for directories and things like that. I just get stuff that I have permissions for and that I can, that is visible to me. However, I can force it to show me everything. If I put a space, it's just right-click. That's all you got to do is right-click inside the Putty window. If I put a space and a dash and A, I list everything that's there, including bash .bash logout, .bash rc, .profile, all this random stuff, and then there are those two blue ones that are just dots. But that lists everything. This -A is an option if I were to go manual ls. Let's see what else we got here. That's another good one. Yeah, we'll try L. So I'll hit Q, and if I type ls-L, I get some additional information. Again, it's Bandit1. It's always the username is always going to be the level that you're on. So you start at Bandit 0 for the first level, and then you go to Bandit 1 for the second level. And is there something that's you're having a hard time with, Noah? Like in particular, I mean? Gotcha. Okay. Well, let me know if you have any questions about anything, and I'd be more than happy to provide more information on why I'm doing these things. Like this LS stuff I'm doing right now, this is not necessary for you guys to do. This is just me showing you that there are additional things you can do in the terminal. You can expound upon commands with the minus character. It's kind of like right-clicking and doing additional things with an icon on the computer. They're known as options. and this is just additional stuff. So that's why the dash can be a problem, because if we do cat and then a minus, it thinks that we're trying to provide additional options for the cat command. If I hit A, and it's just not going to work. So we need to specify that we are trying to cat something that is labeled a minus sign, not cat with some additional options. And the best way to do that is this with a sequence of characters here. I put a period, I put a forward slash, and I put a minus sign. So what exactly does that mean? Well, let me go ahead and just spend some time drawing this. So let's say you have a set of files. And you've got, oops. So you got a set of files. You've got things and stuff inside of the user folder, and you've got texts inside of stuff. Now let's say AU. Hold down Control on your keyboard, Jacob, and press the C key while you are while you have the PuTTY window selected. For sure. Yeah, Control C in Unix-based systems is just a shortcut to kill whatever you're doing. Copy the password by just simply highlighting it. I can copy anything in PuTTY just by highlighting it. As soon as I let go of the mouse, it copies whatever I have highlighted. Okay, I'll just do that again. So let's say you are here. Now, if you ever wanted to reference something inside of this folder, like let's say you have report, you could use, for instance, cat report, right? Makes sense. You could also say cat user, user stuff texts report. And all that is the path to where the report is hiding, because remember, this is all just a hierarchy of folders, and report is inside texts. Make sure you're not pasting anything extra, and make sure you're pasting the correct thing. Also make sure that your username is bandit2 now, right? Because you're on to the next level. So we've got a file system here, and we're just looking at the hierarchy of things. Text is contained within stuff, which is contained within user. Report is contained within texts, which is contained within stuff, which is contained within user. So this is just a path. This is just literally how the computer finds where your file is. If I were to print working directory, or PWD, as you can see, I'm inside bandit1, which is inside home. Awesome, glad to hear it, Jean-Marc. Now, this is a lot to type. You can also type, you can type that, since we know we're inside the texts folder, right? But like, let's say, for instance, instead of it just being called texts, let's say that our folder name was like some really absurdly long folder name that would be a pain to type all the time /report. That would be annoying, right? Now, there are some additional sort of features that exist in the bash interface that would make that a lot easier, but there's one in particular that's very useful to know. Just this period. The period is called a relative path. Just a single period always refers to the folder that you're in, no matter where you are. Wherever you are, the period refers to that. The double period, if you just type 2 periods, no space in between or nothing, represents 1 level up. So in this case, it would be stuff, which contains texts. Now let's say, for instance, you are actually here in stuff. Well, a double period would be user, and the single period would be stuff. So you could express it as cat stuff texts report. You could also say, hey, cat period texts report, and that would mean the same thing. In fact, if you wanted to be super silly, well, forget that. Never mind. Ignore I said anything. So what we're doing here is we're being incredibly explicit about where this password file is contained. It is, in fact, we are referring to the file that is a dash that is inside of the folder that we're in. And this is just because we want to be sure that Putty knows, that Putty knows that we are, or excuse me, the bash terminal knows that we're talking about a file named a dash inside of the folder that we're in. If we wanted to, we could say cat bandit1 / dash. Wait. Okay. Cat home bandit1 dash. And see, there we go. We get the password again. It's the same exact password. Now, I'm going to teach you guys a little bit of a shortcut when you're using Putty, which can sometimes be useful. If you right-click on the little icon up here in the upper left-hand side, you get a whole list of little commands. You got minimize, maximize, the basic Windows commands. Sorry, I just suddenly had to sneeze. Minimize, maximize, the basic Windows commands. You've got close, obviously, which will close it. You've got some special commands. Don't worry about those. Those are for later. You've got an event log. You've got new session, duplicate session, saved sessions, and change settings. Copy all to clipboard, clear scroll back, reset terminal, full screen, help, and about Putty. Now, watch what happens when I hit duplicate session. I open up another session to Bandit Labs. So let me go ahead and log in as Bandit2, and I'm going to right-click to paste that password, and I'm in. Let me go ahead and exit out of Bandit1. Now what? Aha, there's one file in here. This file is called spaces in this file name. This is where we learn another useful thing about the terminal, but this is tricky. Let's try and cat spaces in this file name. Like, should be pretty straightforward, right? Except watch what happens when I hit enter. Are you not able to copy and paste it? Oh, gotcha. Wait, what do you mean? Okay. All right, well, here. Just, yeah, anyway. So watch what happens when I try and cat this file. cat spaces, no such file or directory, cat in, no such file or directory, cat this, no such file or directory, and cat file name, no such file or directory. See, traditionally, well, spaces are another reserved character in the shell. Spaces are what you use to separate different things, obviously. So this is a problem because the way the bash is interpreting this is spaces in this file name is not one file, but actually 4 separate files, each named after one word. So that's not exactly what we're looking for. We want this to know that this is a single file, and there's a way to do that. So just like how we had to be very explicit about what the dash was in the last one, we have to be very explicit about what the spaces are in this one. And you'll notice that I'm putting a backslash in front of each space. I am typing a word, putting a backslash, and then hitting the space bar and continuing. And the backslash is what's known as an escape character. What we're telling the bash is, hey, the thing that comes right after this is actually part of the same file name. This is part of, this file name has some generally reserved characters in it or weird characters in it. So just ignore the fact that normally it means something in the bash and just append this to the file name. Just continue working with the file name as if it had this. And so if I hit enter, it gave us the password because it opened up that file. It realized that those spaces are actually spaces in a file name and not spaces separating 4 different file names. So we got this new shiny new password. I'll go ahead and highlight it. But I am going to teach you another trick. Oh, well, there's that too. When you put them in quotation marks, that also works. I'm going to teach you another trick that's really useful. See, the guys who made the bash, well, and the regular shell as well, understood that this involves a lot of typing, especially, again, if you have some really absurdly long folder name that would be a pain to type all the time, something like that. So here's a pretty useful thing. I'm going to type cats, and I'm going to start typing the name of this file, sp. That's it. In fact, I'll hit SPA. Now watch what happens when I hit the tab key. Bam. It has autocomplete. So the bash also has autocomplete. You start typing characters, you start typing the name of something. Before you finish it, you can hit the tab key and have it autocomplete for you. Now, if it runs into a situation where there are multiple choices, it will complete as far as it can, and then it'll pop up with the names of the, conflicting files or the names of the similar files. And then, let's say you have, let's say, November 3rd week report and November 1st week reports, and you start typing NOV and you hit tab, and it'll go November, and then it'll pop up with these 2 results, or it'll actually do that as well. It'll pop up with these 2 results, and then you can start typing, T and hit tab again, and you'll get the 3rd week report, that sort of thing. So that's what this can be good for. So let me go ahead and make sure that I have this highlighted. I do. It's copied. And I'm going to duplicate my session because I'm ready to move on to the next one. Wait, exit. That's always a good idea to exit and not just close it, because it's ls is your command to see what is in a directory. So now we're going to log into Bandit 3, right? Yeah, Bandit 3. It's going to ask us for the password. Right-click, enter. So, ls. We're given a single blue result called in here. The reason why it's blue is because it is a directory. So now we have two different things we can do. We can ls -a, see everything that's here. We got a whole bunch of other stuff that's not really useful, like you do sometimes, but let's go ahead and navigate to in here, and that is done with the cd or change directory command. That's what cd is short for, is change directory. I'm going to hit cd space and in here because we're telling it where to go. And look at that. Now you can see that in the bash here we have the squiggly line, the tilde, a slash, and then in here. The bash outputs your current location. That's what that is. The little tilde represents the home, which is another one of those relative links, just like the period and the double period. So that's what the tilde represents. It represents the home folder on a computer, on the computer that you're running the bash on. Anyway, so now we're in here. Let's go ahead and view everything. Nothing's there. But remember that -a command I had, where it shows you all of the hidden, or it shows you everything, including hidden files? Let me go ahead and try that and hit enter. And sure enough, we've got a file called .hidden. So let's go ahead and cat.hidden. Bam. There's our password. So just because a file is hidden doesn't mean it's inaccessible. All it means is a file is not normally shown on the bash when you just do an ls. And there is a use, there is a use for that. It's generally to ensure that, the bash doesn't just get filled up with a whole bunch of garbage files that are useful on your computer, but you don't need to see all the time forever. It's good for, making sure that maybe people who are less computer savvy, like it hides files from their view so that they don't just accidentally mess with something, because I can autocomplete it, but I have to basically know where it is in order to autocomplete it. I have to know it's there in order to even start to type it to autocomplete it. So that's the password for Bandit 4. Let me go ahead and duplicate my session, and we'll log in as Bandit 4. Paste, enter, and we're in. So now let's see what our goal is for 4 to 5. The password for the next level is stored in the only human readable file in the in here directory. Tip: if your terminal is messed up, try the reset command. So what exactly does that mean? Well, let's ls, hey, there's in here, cd in here, ls. Look at all these files. File 00, file 02, file 04, file 06, file 08, file 01, file 003, file 05, file 07, file 09, and I realized that I was reading those out of order, but that's okay. So which one of these is it? It's a bit of a pickle, isn't it? Well, let's go ahead and try and cat file 00. Whoops. Remember, it starts with a dash, so we have to be explicit about it. We get a bunch of garbage. The weird static looking squares basically mean that they're characters that the computer can't reasonably translate to, well, they're bits of data that the computer can't reasonably translate to characters. That is to say, letters and numbers and symbols and stuff like that mean things to our human eyes. And then you got this weirdo thing over here, which is just another one of those. I wonder what happens when we copy and then paste it. Does it appear here? Yes, it does. Look at that. Look at that character. It's crazy. Anyway, so that's unhelpful. But hey, it's stored in the only human readable file in the in here directory, human readable. Humans generally can't read computer data, right? And that's what this is trying to do. So like, let me do this. I'll do file and then Right. Again, because you have to be explicit about it. Remember what I did here? Because it starts with a dash. So I had to say that it was inside of the folder that we're currently in. For sure. So, okay. Let's try file 00, just like we did before. And the file command, what that does is that tells you what type of file the file is that you're sending to file. That's the word file, a lot of files. And look at that, it's called data. It is a data file. Interesting. Let's see, file 01. Another data file. Now let me teach you a trick. I'm just going to hit the up key on my keyboard. Boop. And what it does is it populates it with the last command that I sent to the bash command line. And then I can modify it as I please. So all I did was delete the last character, or delete the last number and replace it with a 2 instead of a 1. And hit enter. Look at that, file 2 is data. I'm going to hit up again. What about file 3? 3 is data. What about 4? 4 is data. 5 is data. 6 is data. 7 is ASCII text. This is what we care about. So instead of filing it, let's go ahead and cat it. And sure enough, there's our password. So let me go ahead and highlight that. Duplicate our session and exit out of this one. So now we're on to Bandit 5. Bam. Whoops. Perfect. Now we're on to Bandit 5. So there you go. I mean, so far this is hopefully making some semblance of sense, right? The whole idea is it's sort of teaching you different ways of interacting with the command line and different commands that are there. Not just the command line, the bash, excuse me. Bash is different from the command line. The Windows has a command line or the command prompt. Unix systems have the bash. Anyway, Bandit level 5 to level 6. LS, here we go. We've got our in here directory, CD in here. What do you mean, how did I get ASCII text? As like the file type, I just typed, the command is file and then file name here, and that gives you information about the file, including its type. And ASCII text is human readable because that's what stuff like the bash uses, is ASCII text. Don't worry about what ASCII necessarily means right now. Just the fact that it was called a text file is what we were interested in. So the password for the next level is stored in a file somewhere under the in here directory and has all of the following properties. It's human readable, it's 1033 bytes in size, and it is not executable. Curious? This seems like a lot. Well, let's go ahead and dissect this. So human readable, if we go back a level, is the only human readable file. So you can probably gather from that it's going to be a text file, right? It's not going to be a data file like a lot of them have. Now the 1033 bytes in size, that one's a little bit trickier. Also, what makes it a little bit trickier, let me go ahead and LS. Notice how all of these entries are blue. This means all of these individual entries are actually directories. Well, no big deal. Let me go ahead and change directory to maybe here 00. You just cat it. You just cat file 7. That's all you got to do. Just like we've done with all the password files before it. So here's the thing. each one of these directories actually contains quite a lot of files in them. But first things first, file period / minus file1. Remember, because this starts with a minus sign, so we have to make sure that we're very explicit to the terminal that we want to look at file1, a file called file1 with a dash in front. There is no option that is called file1. Let me hit enter. ASCII text with very long lines. Interesting. Let's go ahead and try it. We'll cat it. And they weren't lying. That is a lot of stuff, and it's all just kind of nonsense. But this is, I mean, it's a text file. It's human readable, right? But the next thing says it's 1,033 bytes in size. So let me introduce you to the next command. It's called du. This is file size. I don't understand why it's called du, but let me go ahead and use the du command on file 1 and hit enter. Actually, a command to go back a directory, remember the relative paths that I was talking about before, where the single period represents the directory that you're in and the double period represents the directory above it? So what if you tried to type cd and then 2 periods and hit enter? Puts you back a level, doesn't it? There you go, yeah. Okay, so this is for what? Well, it just so happens that if we check the manual page for du by typing man space du, man is always short for manual, so if you ever want more information about a command, you can use the manual command on it. So man space du will give us more information about du. Estimate file space usage, du option file, so on and so forth. That's what du is. Summarize disk usage of each file recursively for directories. So if you use du on a folder, it will tell you the size of the entire folder by telling you the du size of each individual item inside the folder. Anyway, mandatory arguments to long options are mandatory for short options too. Okay, so we've got null, all, apparent size, block size. Aha, look at this minus b. It's bytes. That's what we're curious about. We want to find the file size in bytes, because as it stands right now, we have not been getting the output in bytes. So if I do du minus b and then period / file1, it's 1,039 bytes. It's too large for our answer. So close yet so far. Okay, so this gives us another avenue to explore. But here's the deal. Let me ls again. Look at all these files here. Okay, file 2 is 9,388 bytes, far too large. File 3, 7,378 bytes, far too large. Then we've got 6 more files here, and if we go up a level, we've got 18 more folders beyond that. This is a lot of work. Let me show you a trick. Remember how it said it? Well, let's actually skip that for now. We'll go cd, maybe here. I'm still going to show you a trick though. So here's what I'm going to do. du minus b and then an asterisk. Well, actually, a period, a /, and then an asterisk. Boop. Look at that. It just gave me the file size of every single file inside of this folder organized nicely. So now file 1 we know is 1039 bytes, file 2 is 9388, file 3 is 7378, spaces file 1 is 6118, so that's also one of the things that's going to throw a wrench into things. This is actually only 3 files. Yeah, there's just you can look it up. You can try finding it that way. See if you can't find like a bash command that will do that. I'm going to leave that up to you. Find out. Because see, that's going a little bit above and beyond what they're asking here. And I think that's interesting. I think you should, yeah, see if there is something there. Because technically, I mean, you guys are supposed to be doing this stuff on your own. But see, if you do that, you could actually go a long ways towards making, you know, your life a lot easier. So maybe try the, I don't know, the manual page for find. Wonder if there's something here. Maybe. All right, fine. We'll go ahead and do that. I wanted to show you the asterisk one as well because that's something that can be very useful for bash. But yeah, we'll go ahead and do that as well because it can take a while to search through all these regardless. Anyway, so real quick, the asterisk is referred to as a wildcard. So you remember how in the last one there was file 00, file 01, file 02, file 03, file 04, file 05, file 06, so on and so forth. What do all of these have in common? Yeah, but even beyond that, the commonality between all of them is file 0. In fact, let's say we had a file 10. That's just later on. But the commonality between all these is file 0. Now, you remember how I did these individually? I was like file, blah, 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 file 00, and I did them all one at a time. I could do this. What I've done is I've stuck a wildcard in there. And this is kind of like a search, sort of, kind of. What it's going to do is it's going to look at all of the files in the folder that we're in, all the files that start with a minus sign, the word file, and a 0. And it's going to give us information on all of them. So let's see here. If I were to file maybe here and then an asterisk, it would give us information about all of these because they all start with maybe here. Yeah, for sure. Well, that's one of the things they say is to use Google for this as well. Now, here's the rub. Now, if I search for file maybe here and then an asterisk, and I got all of the maybe here's. Now watch what happens when I search for file maybe here, 0, and then an asterisk. I just get the 0 through 9. the first 10 directories, because this is maybe here 1 and further along. So that one doesn't count. It's going to look strictly for the file as it starts, right? Like it's going to look for files that start this way and give you all of them, regardless of how many characters are after this. Like we could have a file called file 0, like that, and that would be valid as well, because it starts with file 0, just like we have here. So the wildcard can be very useful for that. But you know what? Let's try find. Actually, let me trick the man for find again, because that will save us a lot of time, and I guess I should stop being coy about it. So size n, 1033 bytes. Okay. So we're going to do find size 1033C. Wait, what? Could have sworn that was correct. Oh, there's a space. Why is that unknown? Oops. Total 88. Oh, there you go. Okay, so you do have to type. Okay, you do have to type it all out. There you go. See, the man page sometimes doesn't exactly help out, but nice work, Noah. You did it. Man page doesn't always help. It tells you that the size search term is just, or the size option is just S, but you have to type out size in full. But yes, if you search find, like if you use the find command, you search for a file of size 1033 bytes, which is what the C is short for, you get a file path to a specific file. And in fact, even though we're sitting in the in here directory, we can actually cat from here. Look at that. We're just going to go ahead and cat and write the file, like the full file path. Oh, right, because it's 07. Attention to detail can be useful. And look at that. We've got a password in there. Looks like it's about the right length for a password. Go ahead and highlight it to copy it. And we'll duplicate the session. Take a look at Bandit 6. Paste, enter. Now let's take a look at what's going on between level 6 and level 7. The password for the next level is stored somewhere on the server and has all of the following properties. It's owned by user Bandit 7, it's owned by group Bandit 6, and it's 33 bytes in size. Let's just take a look. Nothing, ls, la. This will give us a whole bunch of information. So we know it's stored somewhere on the server. That's the tricky thing, right? Let's print the working directory. We're in Bandit 6. I wonder what happens if we go up a level. ls minus la. Look at all of this. Oh, all these different ones. These are all the different challenges. So maybe not helpful. We'll go back into Bandit 5. 6. Bandit 6. Yeah, that can be the case if you're running through a Unix terminal already. Anyway, actually didn't realize what time it was. So why don't we go ahead and call it a day for now? Um, yeah, I know. I think we'll be moving on to more about internet security. I'm glad you're enjoying it, actually. I'm really glad because you spent that time looking it on Google and figuring out the answer there, because that's part of what this is about. And this is part of why I enjoy this so much, because you also learn how to navigate this stuff. Actually, I have another job now, in which a lot of my job actually involves using SSH to get into remote servers and, you know, changing information that needs to be changed. So this stuff is A, right up my alley, and B, actually pretty interesting. But anyway, let me go ahead and do the poll questions, and then we'll go ahead and question and answer time. And if you don't have anything, you can go ahead and head out and go ahead and have a wonderful weekend. Go ahead. I'm just going to repeat myself. But anyway, yeah.